We're going to talk about resistors. And as we pointed out before, resistors have a symbol like this, a single element. So what you can find out is basically the voltage between these two nodes given by V. And if the resistor has a resistance of R, and you can look at the current I, Ohm's law states that V is equal to I times R, where I is measured in terms of ampere that we described, V is measured in terms of volt, and what you have then, R is measured in terms of ohm. In other words, if you try to plot the curve of V versus I, what you have done is a curve which is a straight line with a slope of R. And this is what Ohm's law said. Basically, the voltage is proportional to the current across a resistor. And that slope of that resistance, of that line is the resistance measured in Ohm. Now, I would like to just go over this very simply, and let's say a resistor is a circuit element that dissipates electrical energy, and usually it converts that electrical energy into heat. We will add devices that are modeled by resistor include the light bulb, heating elements such as stoves and heaters, and even wires typically would have resistance and turning electricity into heat. And very often these are undesirable resistances, and we call that parasitic resistances, and many resistors on circuit diagram model are unwanted resistance in transistor, motors, etc. So we would use what is known as a lump circuit element, put the resistance along the entire wire as if it's a single resistor. Now, I want to think a little bit more about what really are resistors. Now, the question is, V equal to IR, there's an equation here, very similar to F equal to MA. The nature of this law called Ohm's law, I could ask a question here. Is it a definition, very much like F equal to MA is a definition? Or is it a derived result like E equal to mc squared in Einstein's special relativity equating energy with mass that is derived using a thought experiment? Is that sort of thing kind of a derived result? Or it is an experimental result that is coming out from the result of an experiment? Now, I give you the answer here that basically V equal to IR, even though it's a very simple equation, really is an experimental result. It's only true for resistors. A lot of other elements, such as a diode, would not follow this relationship between V and I. It would have a very different relationship. So really, this is true because Professor Ohm in Germany did a measurement by changing the voltage, and he measured the I and plotting that. He got a straight line for the VI relationship for resistors. Now, I want to ask an even more difficult question is, why is this equation true? Why is V equal to IR? Well, you can simply say, well, that's the reason why it's true is because Professor Ohm found that in an experiment. That's true, but still, how do you explain the phenomenon of V equal to IR? And for that, you really have to understand that from the point of view of the kinetic theory of matter. And here I have built a small model which represent the pins are basically atoms in a lattice. Say, for example, a metal will have atoms arranged in a lattice structure. and I have an electron here, just a bead, and electron would be moving downhill and hit along the way the atoms and bounce around. So what you see here, that it would go certain distance on average before it hit an atom, and then it bounced backward and then accelerate again downward. So in a sense, the voltage is very similar to the voltage potential. It's very similar to the gravitational potential here. And we're drawing a mathematical, physical analogy here. So if I raise the height of that board and I drop the bead again, what you hear literally is that the bead hits these atoms much faster because the acceleration is faster by virtue of the sloping of the board. And so in a sense, the time it takes for the bead to go down the board will be inversely proportional to the height that I raised the board with. And if you do a small calculation, the current would be inversely proportional to the transit time of a single bead, but there are multiple electrons going down the resistors. In that regard, that thought experiment of how the electron going down a voltage potential hitting atoms at various places will explain why you would have V equal to IR. So it's important to understand the actual physics of movement of electron inside a conductor. Now there are other types of conductors, something called semiconductors, or we may have other superconductors, and involve movement of electron in other manners that is not like a resistor. And I'm not going to explain too much about that, but again, you have to explain that in terms of the motion of electron in these different kind of media. Now, the mathematical model described here, as I pointed out earlier, is that you have a resistor across which you have a voltage and a current that go through the resistor, and you have the rest of the circuit. So Ohm's law really says that V, which can change over time, is equal to I times I that can change over time times R, and R is a constant here. So you have, if in case V and I are not changing over time, V equal to IR. Now, if you know earlier that we also have the relationship, well, of power is equal to I times V. So the power is a product of the current times the voltage. And according to Ohm's law, we also have V equal to IR. So if you substitute IR into the V here, what you have P is equal to I times R equal to I squared R. So the power really goes up as a square of the current. Or if on the other hand you make the substitution of V I equal to P over V, in this case here you can also obtain the relationship of power not equal to I squared R, but can be measured in terms of V squared over R. So you can either take this form or this form, P equal to I squared R, to derive for given R what is the power for given current, and you can pick two, and you can find solve from this equation the quantity that you want to find. So you have the P as a function of time is equal to I squared R, or equal to V squared divided by R.